back. Let's talk about using and expressing measurements. We're going to talk a number of things, and this may end up being 2 or 3 videos just for section 1. So let's talk. So, how do you write numbers in scientific notation? And hopefully, this is not new to you, and this is just a review of things you've already learned. If not, you may need to ask a lot of questions in class. So, how do you write numbers in scientific notation? Well, the first thing you need is a measurement, and a measurement is something that you've somehow gotten a number for. If it's a ruler, if you're measuring length, you've used a ruler. If it's your mass, you've used a scale or a balance. And so you can use a stopwatch to measure time. There's all sorts of ways of making measurements. So in chemistry, we use often very, very large numbers or very, very small numbers. And to do that with something like number of hydrogen atoms in this example, that's a lot of zeros. In fact, it's 23 decimal places if I were to put this in scientific notation. And so all those zeros makes it very difficult to write and keep the number straight. So you're going to want to use scientific notation. In fact, it's going to be required. So, when we have something in scientific notation, we need some number that is a coefficient and it is raised to the power of 10 raised to some power. And that first digit has to only have one place prior to the decimal point. So in this example, I would move the decimal place from all the way over here at the end of all my zeros in between the 6 and the 2. When I move it that many times, I have to figure out how many places it would go. And then I'm going to take 6.02 and I'll get rid of all those trailing zeros. And then I would use times 10, and then the exponent would be 23 if we count how many places over we move it. So, scientific notation, the coefficient is always a number greater than or equal to 1 and less than 10. So it's either 1 point something or up to 9 point something. And the exponent is always an integer. And a positive exponent for your times 10 indicates that we've moved the decimal place in a particular direction, and I'm going to talk about that in a minute. A negative exponent means that I have to divide by a number of powers of 10, or I've moved it in a different direction. So here we have something where we are moving the decimal from the right to the left. And when we move to the left, we get a positive exponent. And we have moved in this first example of 6,300,000, we've moved it 6 places. So these 3 zeros and then these 3 places to go in between the 6 and the 3. Here we're going to move the decimal place in the same direction. It needs to end up between the 9 and the 4 so that I have just one digit prior, bigger than my decimal. And then we just count how many places over, in this case 4. If we have numbers that are decimals, then we are going to move the decimal point from the left to the right. When we move to the right, we get a negative exponent for the number of places we've moved in that direction. And again, we have to move just to the place between the first two, or just to the right of the first non-zero digit. In this case, it would go next to the 8. In this example, it's going to go between the 3 and the 6, or 3 and the 7, sorry. So we get 3.6, and I moved it 3 places. Okay, so that's how to put numbers into scientific notation. If I want to then multiply or divide with scientific notation, it makes it very simple. We multiply the coefficients, the 2 times the 3, and we get 6. But then the times 10 to the 4th and times 10 to the 2, we're going to add those exponents, and we get 6. You can also do this in your calculator, and that's what we will spend time in class on, is going through using the calculator. What if when we multiply two numbers together, we get a decimal? That's fine. Keep the decimal, 8.4. When we multiply 2.1 times 4.0. In this case, we have 3 minus 7, or 3 plus a -7, and that's going to give us -4. And so we just add those exponents. When we divide the numbers and we subtract the exponents. So it's pretty straightforward as well. And in fact, your calculator will make this so much easier for you. And so we get 3 divided by 6, we would get 0.5. And then 5 minus 2 is going to be 3. But we have to have that decimal place moved over to the right of the 5. So we're going to have to move the decimal to the right. So I would decrease the power of 10 by 1. When we add and subtract with scientific notation, we have to have the powers of 10 to be the same. And so we will move one of them out of scientific notation so that we can add or subtract. So here we have these two numbers. Their power of 10 is not the same. The easiest thing to do is move the 8.0 times 10 to the 2 and make it 0.80 times 10 to the 3. We typically goes to the larger positive exponent so that when we add them together, we have them in the right places. And so it makes it easier. And I will work examples of this in class. So I want you to try doing these. If you can't do them, please ask me in class and I will go over them in class so that we are sure you know how to use your calculator and get the right answer in scientific notation. So the mass of one molecule of water written in scientific notation is 2.99 times 10 to the negative 23rd grams. What is this mass in standard notation? So that negative exponent is telling me I need to move my decimal point to the left. And I need to move it 23 times. And so when I get my answer, it would be a lot of zeros. This is why we don't use standard notation for very large or very small numbers. So I'm going to stop here, and the next video will be on accuracy and precision, as well as error. And I will see you in just a little bit. Thank you.